Okay, so what I have here are three charges. I have a positive charge, a negative charge, and another positive charge. So we can even think based on the size coulombs, 1.602 times 10 to the negative 19th coulomb. This is a proton. Here's an electron, there's another proton. And you see the negative sign there in the middle. But I also want to draw your attention to the micrometers, so a very small distance between here. 1.32 micrometers, a little bit larger here, that's why I put a little bit more space, 4.85 micrometers. So we want to find out what is the force on Q2. Well, I'm just going from left to right, so let's call this one Q1, this is Q2, and this is Q3. So what is the force, what's the force in newtons on this charge, on this negative charge, because of that proton and because of that proton? They both have the same, well, they all have the same charges besides this one being negative, 1.602 times 10 to the negative 19. And we also see that, well, this electron here is kind of in the middle of a tug of war. We have this proton attracting it that way at the same time that proton is attracting it that way. So we can say, well, whatever force that is pulling it that way because of Q1 has to compete with the force that's pulling it that way because of Q3. And I imagine, since they're all the same, that Q1 force is going to be a little bit larger than Q3 because it's farther away. This one being closer, it's going to have more of an effect than that one is because they're all the same charge. That's why this line is a little bit longer, because what we're going to do is we're going to subtract these two once we get the two forces. And we're going to take, and they're both going to be negative charges because they both involve this negative charge. So there's an attraction there. Attraction is always negative in terms of forces. An attraction there, so that's going to be negative. So you have two competing negative forces, one going in that direction towards Q1, the other going towards Q2. So you already know fairly well, because this distance is a little bit larger, that this negative charge is going to go that way. We just don't know the force in newtons. So how do we set this up? Well, I've written down a few things for you already. Well, oh, by the way, before we do that, I want to first do the conversion with you. So let's take this 4.85 and 1.32, and let's convert it from micrometers into meters, because in order to use the equation, F is equal to K Q1 Q2 over D squared, we actually have to convert the distance into meters. So let's do the 1.32. So what do I know? 1.32 micrometers, I'll put that over 1, and I know the relationship is that 10 to the 6th micrometers, all right? So a lot of this really small unit makes 1 meter. So then when I do the math on this, I'm going to just get 1.32 divided by 10 to the 6th, which is times 10 to the negative 6. That's going to be in meters. So I would do the same thing for the 4.85 number. So that is going to be fairly simple now, because I'm going to use the same number, 4.85 though, instead of 1.32. So there are my distances now in meters. So that's the first thing I'm doing. And you see on my sheet here, I've done those micrometers now into meters. So what am I doing here? I'm going to do two calculations. One, what is the force in newtons of Q1 on Q2? And then do a second one, well, what's the force of Q3 on Q2? So they're very similar to each other. You have our K, Q1, Q2, and they all end up being the same. Why? The constant's the same. Here's our positive charge, which is Q1. Here's our negative charge, which is Q2. For this one, here is our K, here is our positive charge. In this case, it is Q3, and the effect that it's going to have on this negative charge, which is Q2. So if you notice, the negative charge is always that second one. So the top number, the numerator, will be the same for both of these. Why? You have a positive, positive, negative, positive, positive, negative. The bottom number is the one that's going to get a lot of people if you don't do it correctly. It's 1.32 times 10 to the negative 6, but you have to square that. and if you don't square it, your number is going to be a little bit too big. So I'm going to do the math right now, and I'm going to say 9e to the ninth. I'm going to multiply that by 1.602 to the negative 19, and I'm going to multiply that by 1.602 to the negative 19. So my numerator is 2.31, right, times 10 to the negative 28. We'll talk about units in just a second. So I've got a coulomb, and that's going to cancel out with the coulomb squared on the bottom. This meter squared is going to cancel out with that meter squared right there. But don't forget I have to distribute that. So I'm going to go 1.32 to the negative 6, and that's going to be squared, which is 1.74 times 10 to the negative 12. So we're dealing with really small numbers here, and this is all going to be in newtons. So now I'm going to do my final answer of 2.31 e to the negative 28, and I'm going to divide that by 1.74. Oh, by the way, this should be a negative number. 1.74 e negative 12. So I'm going to get, I'll write it over here, 1.33 times 10 to the negative 16. And that's going to be in newtons. So this is going to be a negative number because I know it's going to be drawn towards this one charge over here, which we're calling Q1. So it's going that way with a force. And I will write it as negative 1.33 times 10 to the negative 16 newtons. All right, so let's do the other one. Well, I know the top number should also be negative 2.31 times 10 to the negative 28. That's going to be in newtons. This time I'm going to have a different denominator because it's going to be 4.85 e to the 6th negative, and I'm going to square that. And this number is going to be 2.35 times 10 to the negative 11. Okay, so now I'm going to do 2.31 e 28 negative, divide that by 2.35 e 11 negative, and it's going to be negative 9.83 times 10 to the negative 18, slightly smaller, 10 to the negative 18 versus 10 to the negative 16. So it's definitely a slightly smaller force being pulled in the direction of, in this case, that one's going that way. This one we already know is going that way because of the attractive force with a force of negative 9.83 times 10 to the negative 18. All right, so I know there are these competing forces on that middle charge. So if they're competing forces, regardless of the negatives in there, I know I'm going to have to subtract these two. So my two numbers right there, 1.33 e 16 negative, I'm going to subtract from that 9.83 e 18 negative. So the overall force, so the net force on our Q2 charge is equal to 1.23 times 10 to the negative 16 newtons, and it's going to go in the direction of that charge over here. So it's going to overall go that way, and it's going to be 1.23 times 10 to the negative 16 newtons. Right? So if you notice, doesn't make it that much smaller. All right, again, I'm going to put a negative sign in because I know it's going to be attracted to that Q1. It doesn't make it that much smaller because in comparison, this is fairly weak compared to that. So yes, it takes the force down a little bit, that attractive force that way, but not a lot compared to its original 1.33 times 10 to the negative 16. Remember, 10 to the negative 16 is really small. They're the same as well. So now I'm looking here, and this one is a slightly larger number than that one, which means that there's less force being pulled in that direction. So the overall net force is going to be lessened because of this competing force due to the Q3 charge, but not a lot, not a lot. So hopefully that is helpful.